Hi, my name is Millie and this is my Composite Hybrids interim presentation. This project will investigate the relationship between biology and computational design thinking as a tool to drive the design of a regenerative and resilient architectural solution, focusing on coding and scripting, 3D printing, and material innovation. Computational design can be simplified to a complex form derived from simple code, and biomimicry is design inspired by the way functional challenges have been solved in biology. My first source of inspiration to this relationship is the Aguahoya by Mediated Matter Group. It's a collection of artifacts designed using algorithmic patterns, 3D printed using three most abundant materials of cellulose, chitosan, and pectin, found in leaves, insects, bones, to create biodegradable composites that respond to humidity and heat. My main takeaway from this case study was building materials derived from organic matter, printed by a robot and shaped by water. Another source of inspiration was a work of Akim Mengi's. This pavilion took inspirations from a lobster's exoskeleton, more specifically the morphology of the fibers and how they're optimized for stress and load distribution. His pavilion used nature's fundamental of more design, less material. Another of his works looks at the environmental responsiveness within material properties. This exhibition in Paris took inspiration from pine cones and how they open and release their seed once they fall into the floor. The changes in humidity cause the fibers to open. He recreated this idea using wood in a humidity-controlled case. The timber expanded and contracted in response to the humidity, and the opening and closing was an autonomous passive system. This case study by Zaha Hadid explored the concept of differential growth, a growth pattern evident in nature, in which the expansion and diffusion that arises from a single continuous curve guided through a simulation is constrained to a reference surface. The final iteration was 3D printed. Jumping to our site, the Sydney Olympic Park, located in the centre of Sydney, 16 kilometres from the CBD and 7 kilometres from Parramatta. It's located on the Parramatta River catchment with a strong relationship to its surrounding estuary, and it's a node between the two ever-growing CBDs of Sydney. The urban fabrics are quite dense, but with a large percentage of conserved and protected land, Sydney Olympic Park is less dense. The traditional custodians of the site were the Wangal people. These lands stretch between the Gadigal and the Barramadigal lands. The estuary ecosystem provided Aboriginal people with resources and means of travelling for 28,000 years. During European settlement, the site underwent dramatic change and degradations in land and water quality. An abattoir, industrial waste dump, brickworks, but in the 80s it underwent great remediation and renewal, preparing itself for hosting the 2000 Sydney Olympics. And today it's a premier destination for sports, leisure, recreation, and natural conservation. There's a 2030 master plan that has been prepared, which ensures that Sydney Olympic Park will become an active and vibrant town centre whilst protecting and enhancing its public domain and parklands. More than half of the land provides habitat for native flora and fauna. This includes coastal salt marshes, mangrove forests, wetlands, reserve forests, and a discontinued brick pit turned into a frog conservation area. There are four main wicked problems that the site is currently facing: more water, more salt, more people, and more heat. But these four problems provide unique opportunities to design resilient and regenerative architecture that adapts. Looking deeper into the sea level rising, the site is susceptible to dramatic changes in coastline over the next century. Altered rain patterns, sea level rise, lack of tidal exchange, and ocean acidification causes many issues, including algal blooms, that suffocate estuaries, native fish, birds, and mangroves. Mangroves can tolerate inundations, but the high sea levels are drowning them. Wetlands and mangroves are vital ecosystems that reduce the impacts of these wicked problems, so protecting these ecosystems will help protect us. The site has three main sectors: Armoury Park, Haslam's Park, and Bicentennial Park. The proposed Discovery Centre will be located in Bicentennial Park, as it has a strong connection to these vital ecosystems. The project will address three chosen UN sustainability goals: responsible consumption and production, life below water, and life on land. There is a unique opportunity to build with local and innovative materials using water ecosystems to drive design, and to further enhance Sydney Olympic Park's great initiative to protect local biodiversity and future development. The design strategy began by looking at the site pressures, more specifically at those algal blooms, using biomimicry and computational design to drive the investigation of a material innovation. The centre will be made out of biocomposites grown on site. Step 1 will be looking at the abundant materials on the site to design a 3D printed biocomposite structural template that follows natural growth patterns. Step 2 is using mycelium for the structural infill. The result will be architecture grown from its environment to eventually return to where it came from. This explains the concept of using the abundant but excessive natural material of algae and turning it into a printing material for a robot to build a structure. This structure will follow differential growth patterns, which is biological growth in nature is differential, meaning it responds to environmental stimuli, varying growth rates through space and time. I investigated this pattern using a grasshopper script, expanding and diffusing a single curve within a boundary. 10 iterations were developed, and I looked at different ways of interacting between these iterations, including stacking and lofting. I then 3D printed this, which could potentially be a template or mold for the next stage of mycelium study. The next phase was looking into mycelium composites, which are created by introducing mushroom spawn into agricultural waste within a template. The mycelium feeds on the straw, binding the fibers to create a solid composite. Mycelium requires a template to grow in. This may include a mold or scaffolding. And I'm currently growing my own. It requires a substrate such as straw, sawdust, and additives such as calcium to promote the growth and the actual spawn. I'll eventually dry it out and end the growth once it's successful. And then once I know how to grow it properly, I want to try growing it within a template. I made this one out of cardboard using grasshopper, taking inspiration from Barbara Imhoff's studies. And here is an initial concept for the Discovery Centre. So having mycelium be cast into those differential growth modules and clustered on site. And here are some initial 3D visualizations to get an understanding of the spatial quality. And here is an attempt at a layered meta drawing. So I want to address the unique spatial experience and a centre that focuses on innovative materials that are grown abundantly on site, eventually decomposing and promoting a circular construction thinking. Thank you.